Okay, welcome back, ya shabab. I think you can hear me right now. I hope that the night of the exam was not stressful on you. And I hope that so far the average of the multiple choices is around 66, which is very good. Not too bad, provided that we don't know if anybody has cheated or not. That's something else. Today we are going to continue the discussion on chapter number 7. We will actually continue solving the problem which we stopped at. I'm just trying to pull out my notes here.
دكتور
Yes.
معلش بس قبل لا تبدأ بكلمك بنقطتين.
تفضل.
أول نقطة اللي هي الفورمولا شيت. أنا شايف طلاب ثانيين عند سكاشن ثانيين مو أكثر من فورمولا شيت، لا طابعين الهوموركات وكانت معهم واستخدموها. ما أدري عن الدكتور حقهم. حلو. ثاني شيء بالنسبة للكاميرا، إحنا اختبرنا كويز وحطينا كاميرات وشفت كيف كانت هوريزونتال، وقبل الاختبار كنت تقول لنا إن يا شباب أنا علمتكم وزي كذا، بس إحنا في الكويز كنا حاطين نفس البوزيشن حق الكاميرا. ما أدري وش اللي اختلف يعني.
اسمعوني يا أخوان، أنا I mean there are limitation within Zoom is not a surveillance software. I am putting it there, and in the day of the exam, unfortunately, there are students who insisted إنه عندهم مشكلة. I could have been so rude, or I take a chance and know this student is intentionally doing this. He wants to cheat and let me kick him out. I can do that, but it might be too extreme. Now, I understand, those students who violated the instruction, okay, did it, but I was keeping eye on them. I actually was watching the student from my tablet because it enables me to at least look into like 4 students at a time. If I look at you at the computer, I look at like 20 maybe something student at a time, so I cannot observe clearly what are these guys doing.
لا دكتور، I'm not talking about our sections.
السكشن الثاني يعني ما شغلوا الكاميرا؟
لا سكاشن الدكاترة الثانيين شغلوا الكاميرا. But regarding to the formula sheet, they printed the homeworks.
أنا
يعني مو بس page واحدة وجه وقفل.
أنت قلت لي الآن المعلومة. I just knew about it. في طلاب كلموني عن الهومورك before the exam, like at 1 p.m. وقالوا لي إنه في أساتذة سووا له extension. إحنا كنا متفقين على الساعة 2. I am pretty sure. But ليه؟ لأن الكل كان يقول نبغى نحط السولوشن للطلاب عشان they can have time to see it. I went right away. I talked to the coordinator and then I adjusted it at 4. And I told him, and my student told me that there are students who speaks about, midnight or something. And he promised me he will talk to the other instructor. But you have to understand one thing. When you told me now, I just knew about it. Yesterday, I didn't know. So how do you think I will know about it? يعني do you think إنه إحنا جلسنا مع الأساتذة واتفقوا وقام واحد قال انتبهوا ترى أنا طلابي أبي أدلعهم أحط لهم عادي الهوم وورك وذا كيفي وإحنا نجي نقول والله كيفك إحنا ما نسوي كذا. No.
لا بس أنا مستغرب.
I am also surprised. I am also surprised. I'm gonna again talk to the coordinator. What do you want me to do? I will talk to him. I will clarify it. This is the best now. The exam has finished and I don't know what to do. I didn't know. Anyway, we'll see يا شباب إن شاء الله. We'll see. I'll try to grade the written questions as soon as possible. Even the university has postponed the midterm warning until next week, just because of us, the sections who had just done the exam. Okay, so and hopefully I will do that before, inshallah. Okay. So last class, ya akhwan, we were talking about this problem, which was saying that there is a rectangular beam, actually a square beam of a dimension B, and this beam is made up of a steel, and it is cantilevered, and there is a cyclic loading on it. The cyclic loading is completely reversed, and we were given F. We were told that we want a life of 10,000 cycles with a factor of safety, this is NF, with a factor of safety NF, which is equal to 1.5. So, and the load here is 1,000 Newton. The length is 0.8 meter. So what did we do? We said, okay, we cannot move with fatigue. There are correlations between like the size factor and other. So we need a size. So what did we do? We went and estimated a size based on yielding. So we said that we will assume that the maximum stress, which turns out to be 6m divided by b cube, is the same as the yield stress divided by the factor of safety. Look at it. This is the yield stress divided by the factor of safety. Is this correct? No. But إذا تذكرون يا أخوان, when we first introduced chapter 5 to you, what did we say? We said that design against yielding is a necessary but not sufficient condition. That's what we said. And this is a good example for it. Even later in the coming slides, you will see that we will tackle problems. And when we try to check the safety of the component, the first step that we will do is to check whether it is going to fail because of yielding from the first cycle. Why? Because if the load is too high, just by going up the first reversal, actually, you may yield the material, or you may yield it in compression. Who knows if the material has strength and tension different than in compression. So from that, we estimated that B is equal to 28.5. ليه؟ لأنه SY is given, N is given, M is calculatable, so you can find B. Then what did we say? We said that KE, the reliability factor, is 1, KD is 1, KC is 1, and we left only with KB and KA. KA, it was hot rolled material, so it wasn't difficult to find. We know the ultimate strength of the material, and we know it is in megapascal, and we know it is hot rolled, so we can find KA. For KB, we have a square geometry, so we use a rectangular equivalent, the equivalent diameter for rectangle, and then we substitute the equivalent diameter to find KB. Then we found SE, and now when we found SE, we said that we should go ahead and find A and B. So for A, which is equal to F SUT squared divided by SE, we have 0.9 multiplied by SUT. If you remember, it was 570 squared divided by SE, which we just calculated, and it turns out to be 157.5. And this is going to be 1671 megapascal. Sometimes we forget to write the unit for A, but it is actually in megapascal. Okay. B is an exponent. It doesn't have a unit, so it is minus 1/3 log, and then F SUT divided by SE. That's B. So this is, if you substitute the numbers, you will get this one as minus 0.1709. Two things, two notes يا شباب. النوت الأولى إنه ال A has a unit of stress. النوت الثانية إنه ال B always negative. Why? Because if you look at the stress life curve, the stress life curve, you have a curve which is like this. That's the slope. This slope is negative. So يا شباب لما تسوي غلط في الكالكوليشن and you get a positive slope, what does that mean? What does that mean? تدرون ايش معناها؟ معناها ان عندك material, if you increase the stress, its life increases. That's funny, right? It's like this. That's a stress like curve. No way. You increase the stress amplitude, you decrease the life. Do you understand? So we just found A and B, okay? And then what did we get here is that we get sigma reversible is equal to N sigma max. Now look, we applied the factor of safety on the stress. Why? I'm gonna tell you why. Just it is equal to what? Is equal to 1.5 multiplied by how much was the stress? It was from here. I think we found it. Did we? No, we didn't. So the stress, ya shabab, is 6 multiplied by 800 multiplied by 28 point. This is, where is it? 28.5, the B. This is the equation. So 28.5 multiplied by 10 to the power minus 3 to the cube. And then what would you get? You will get this one as 346.2 megapascal. Now, let me tell you, if you go and now find N is equals to sigma reverse, which is 346.2, divided by A, which is 1,671, to the power minus 1 over, let me make space for myself over here. So this 1.1709. How many cycles did I get? How much? 10,004 cycles. Now, why I'm doing this? What we were asked to do, ya shabab, what we were asked to do is to find the dimension, okay, the dimension B that will give me 10,000 cycles. First, to answer the question, why did I multiply the factor of safety by the stress? Well, if we have a material property, okay, ya akhwan, then what do? If we have a material property like the endurance limit, for example, we can divide it by the factor of safety. Or we can amplify the stress, assuming that instead of I'm applying 1, I am applying 1.5. That's the idea. I mean, if you look at the equation, okay, you will see that in this equation, sigma, equals to A N F to the power B, the best way to apply the factor of safety is to assume that your stress is multiplied by it. Okay? But if you have the yield here, the best way to apply the yield stress is to assume that the yield is divided by it. It's just the best way. Okay? So now what happened is this. There is one little issue with, I think, ya shabab, you know what? I think I did something wrong over here. I solved the problem after checking. I get the solution after checking the. Oh my God. Just wait a second. Let me see. Okay. In here, we got the factor, the endurance limit as 153. Okay. So when we calculated, let me show you this. 1/57. Yeah. Let me show you. The calculation here is a little bit off. So when I calculate this, it will be 1715.6. So if you calculate with me using your calculator, I'm pretty sure you will get the numbers right. This is 0.1747. It's an exponent which is gonna make يعني the life is sensitive for it. So usually those exponents, the 1 to the power b, they are reported as with a 3 significant figure or even 4. Okay. Now, so what did we do? Let me show you what did we do here. This part I will come back to it. Okay, don't worry about it. It's all landing here. I want to clarify. Now we got A and B. Okay, and then what did we do? We got SF. Yes.
بالنسبة حق البيع مساعة قيمتها يعني أدق من الآن.
كيف؟
اللي هو 0.1709.
0.1709. Well, I want to tell you what is going on. Just wait for me, and then I will come back to you. Okay?
Sure.
Okay. Now, what happened when we calculated A and B? Okay, we got the relation, the fatigue strength equals to AN to the power B. Okay, which means that 1715.6, and then we have a life of how much? Of 10,000 cycle. This was given to us from the problem. The problem says we want a life of 10,000 cycle, and then this is to the power minus 0.1747. If there is an error, I will correct it later. And then, because I need to solve the problem now. So what do I get here? I get a 343.1 megapascal. Now, if I look at this stress SF, which is the fatigue strength, it means that if you give me a life, this is the strength that you can use in order to be within that life. This strength, okay, I am going to say that the fatigue strength, ya shabab, is equal to what? The factor of safety, as I told you, multiplied by sigma amplitude. That's what I just told you. That we are going to use the stress amplitude, we are going to multiply it by the factor of safety, which means that if I go and use the equation 6m over b cubed, it will be equal to what? This value. This is the stress. This is going to be equal to how much? What we found SF which is 343.1 divided by 1.5. Do you understand? ليه؟ لأنه this stress is equals to this. So if I want to find sigma A, I need to take SF and divide it by N. And since I know M and I know this, look what will happen. I know B. I know it is 28. But what I want to do, that B was estimated based on yielding. So I will solve for B, and what did I get? I would get 27.6 millimeter. This is less than what I got from yielding, which is 28. Now the question is this: if a 27 has changed, it means I cannot assume that, okay, my problem is solved. No, because DE is equal to 0.808 multiplied by 27.6. I need to change the diameter. Before, I mean not the diameter, the thickness or the width. If you remember, DE equals to 0.808 square root of BB, which is B squared, which is equals to 0.808B. Now B, in the beginning, we put it 28.5 from yielding estimation. Now I need to adjust it. So what did I get? I get equivalent diameter of a 22.3, which means that KB will be equals to how much? 0.912. So a little different. Now I need to recalculate SE. SE is 0.606, which is KA, multiplied by the new KB, which is 0.912, and then multiplied by the uncorrected endurance limit, and this will give me 157.5. Now look at the difference over here. Here I had an endurance limit of 153, while here, so this is the problem in the calculation, yeah, Hassan. I didn't use the correct endurance limit. We should use the first one that we estimated was 153. So if you look at 153 point how much? 0.4, I think you will get the numbers the same as these one. So this is SE, which is 153. Now, so the new one is 157. And now I need to go and calculate also A and B based on this new one. So if I calculate A, which is equal to 0.9 multiplied by SUT divided by 157.5, I will get 1,671, and B, which is equal to minus 0.1709. This is what you were talking about, yeah, Ali, صح? Because it didn't change. The only thing that changed is the 157. أنا الغلط اللي سويته إنه I solved the problem in the beginning using 157. I should solve it using 153. Because the solution here in my desktop, I was putting the wrong slide. Do you understand me? So now what happened? Do you still have a question, ya Ali?
لا يعطيك العافية.
Okay. Now, again, I repeat the problem. I go and find SF, which is AN to the power B, knowing A, knowing B, and knowing F. F is still 10,000. This is what was asked in the question. So what did I get F? F is equal to 346.24 megapascal. Again, I go and say 6m divided by B cube equals to SF to the power divided by N. SF is determined. This is SF. N is equal to 1.5. M is known, so I am left with B. I go and calculate B, and what did I find? I found that B is equal to 27.5. Now, what was the B that we calculated before? 27.6. You understand? So here, I got a 27.5, which is very negligible, which means that this is a good value. I don't need to keep repeating the calculation. انتبهوا يا أخوان. This issue will come for you in the project. ليه؟ لأنه في البروجكت يا شباب حتضطر إنك تعمل assumption للdiameter. But is that assumption right? Right? I mean, you need to go each time you change the diameter. Remember الchain يا شباب شلون مترابطة مع بعض. Each time you change the diameter, you need to remember that the KB will change, SE will change, A will change, B will change. Do you understand? So you have to be very careful. Each time you change it, you have to change everything again and check it out. I hope you understand, ya shabab, what I am doing. Okay, now look what happened. I rewrite the same problem. Okay, the same problem. But this time, I am telling you that this square rod has a length of 0.8 millimeter. It's the same material. It's completely reversed. The load is 1 + 1 - 1 kilonewton. And then the factor of safety is 1.5. And I said, what is the number of cycles the rod can sustain if B equals to 27.5? You understand? So I am reversing the problem. I'm showing you how can I make the problem about geometry estimation and how can I make the problem about fatigue life estimation. Look, the difference is very clear. In geometry, it's a probably iterative solution. You have to do multiple iterations. And I showed you why. We made an estimate for the diameter or the B based on yielding. We found the strength. And then when we found the strength, we realized that from that strength, if you calculate B, you get a smaller B or a different B. Now, if you want to know which B should you use, you need to recalculate and see, are you getting the close value or similar? If not, then you need to keep iterating. But if you have been given the dimension and you just need to find the number of cycles, the problem becomes very straightforward. Very straightforward. No iteration. يعني تجي وتقول sigma A, which is equals to sigma max, is equal to 6m over b cubed. We discussed the equation, right? I don't need to explain it again and waste the time. So this is going to be 230.8 megapascal. Why? I know B, I know M. The detailed solutions in the slide, Shabab. So I don't need to repeat every single detail. Ka equals to 57.7 multiplied by 570 to the power minus 0.718, which is going to be 0.606. Just the same as before. DE will be 0.808 multiplied by B, which is 22.22. KB will be equal to 0.912. Good. What is SE? SE is going to be 0.606 multiplied by 0.912 multiplied by 285, which is 157.5. Not strange, right? Similar to the number we were getting. A is 1671. B is minus 0.1709. نيجي شو نسوي؟ بس اللهم نقول sigma revolution reverse, reverse equals to n sigma max. So I need to multiply 1.5 multiplied by 230.8, and then I calculate n, and n will come out to be, this value is 346.21 divided by 1671 to the power 1 over minus 0.1709, which is 10,004 cycles. 10,000 cycles, nearly. The same problem. So you can, why I'm doing this again? I am trying to show you what is the difference between designing for a dimension and designing for a number of cycles. Number of cycles هو خلاص قال لك أنت ما يحتاج تسوي حاجة. The material is known. The geometry is known, which is unlikely to happen in real life. What you have in the project, you don't know the material. Be careful يا شباب. تغير الماتيريال from hot roll to cold roll. What's going to happen? KA will change. إذا KA change معناها SE change. عشان كذا يا شباب نصيحتي أنا لكم يعني إنه as much as you can try to automate a little bit of these solutions. على سبيل المثال endurance limit. You better go an Excel sheet and write the factors, okay? And then whenever you change one, everything changes with it, because this recalculation will happen to you no matter what. Okay. Good job. Let me now, ya shabab, take the attendance. It's been a while. We are racing with time, and I stopped taking the attendance for like a week or so. So I'm gonna ask you to turn on your camera as usual, ya shabab. Is there a problem with that? I hope not. Okay, let me share my screen so you can see while I am reading your names. Okay. أبو صالح، أبو سهل، فيصل،
أبو شال.
okay.
أيوة.
أبو شال، yeah, okay. يوسف، بتاكي.
موجود دكتور.
اوكي. ابو خميس
موجود.
قحطاني علي
موجود يا دكتور.
يوسف اليوسف. يوسف are you here؟
اي موجود دكتور.
اوكي. العباد ماجد.
يس أنا.
العلي حسين. محمد. اوكي I see you. عياش حسن.
موجود.
بارك. دوسري.
موجود.
احمد غزالي.
موجود هنا دكتور.
حاجي علي you're here يا معجب. سلطان الحربي here. معجب I don't see him. عبد الله حجاب.
موجود.
سلطان الهوشان. سلطان. عبد الرحمن نزهة.
موجود.
اوكي. خالد العتيبي.
موجود دكتور.
العوفي.
موجود.
فارس. فارس. ثابت قحطاني. فارس you are here. فارس ثابت. I can see you. رمضان علي.
موجود دكتور.
هاشم.
نعم دكتور.
ماجد.
موجود دكتور.
and محمد.
موجود دكتور.
اوكي. احمد سلطان.
موجود.
مشعل. ليامي. وليد.
موجود دكتور.
محمد.
موجود.
بارشيد. عبد الله.
موجود دكتور.
and Ahmed. I think I saw him.
موجود.
Okay, thank you so much. Stop sharing. Okay, now ya shabab, we are going to move on to a very important subject in fatigue, which is the stress concentration factor. Now, the stress concentration factor in fatigue is definitely very important. Why? We have been talking and trying to convince you during the past lectures that if you drop a sample and maybe not, it hits something and there is a little tiny dent on it, then it will cause a big problem. Then what about notches? Now, باختصار يا شباب, a very general word here is that notches are unavoidable. You cannot avoid them. يعني you cannot have a machine without joining. And when you join things by welding, by bolting, you introduce geometric discontinuity. The geometric discontinuity causes stress to rise. انتهينا. So the idea is that it turns out that fatigue has a little bit different than the stress concentration factor that we know from CE203. In CE203, they told you if you have a plate with a hole, okay, then you go and find this radius and then this width, and then there is a ratio between radius and width, and then there is KT, for example. So you know this, you get KT. This KT, when you did it, you never asked your question, is this steel? Is this aluminum? Is this brass? Is this titanium? You didn't ask this question. Why? Because KT, the real name of it is the geometric stress concentration factor. Why? It is mainly dependent on the geometry. اعطيني geometry سواء كانت ربر كانت خشب كانت. Give me a geometry and tell me what is the whole size, the width. I will tell you how much is the stress concentration. Fatigue is different. Fatigue has, let's say, a higher dimension with respect to stress concentration. It turns out that there is a factor which is called fatigue stress concentration factor. And fatigue stress concentration factor depends on KT and another factor. That other factor is related to material, which makes it very interesting. Why? Because يا شباب يعني ما معقول دائما نعتقد بأنه الماتيريال behave the same way. So, for example, احنا لما تكلمنا عن الفتيك قلنا بأنه if you look at the material under the microscope, there are grains, right? And we told you that fatigue cracks start maybe here and then it grow, and then, by the way, depending on the grain let's say, let me call it grain boundary strength. You know, some material, we know this. إذا تذكرون في الماتيريال ساينس يا شباب علموكم قالوا لكم بأنه we can do grain or material strengthening mechanism by which we diffuse carbon into the grains, or we can refine grains. So if you have a material with very little grains, it will behave different than material with large grains, especially when you introduce crack inside it. Why? When you have too many grains, for example, a crack will have to find a way between these grains. ده يعني كأنك أنت تيجي وتقول هذا مكان مزدحم وهذا مكان is less crowded. And if you think of yourself as a crack trying to move on, it will be different. If there are too many people, can you push them and go through or not? So it makes a lot of sense that that the stress concentration factor in fatigue will depend on the material. You tell me this is a fine grain material, you tell me this is a large grain material. Some materials have more ductility, some material have more hardness, and this is just, it makes a lot of sense. So what are we going to do in here? We're going to say that the maximum stress for a component, like here, if I apply load over here, this load is called sigma 0, which we call it the nominal stress. What we want to know is sigma maximum, which usually happen here, sigma maximum. السؤال لما درسنا CE قالوا لنا اضرب sigma 0 by KT and then you can find sigma maximum. Well, this doesn't work مع الفatigue. What we are going to do, we are going to multiply the sigma nominal by KF for normal stress. And for shear stress, we are going to call it KFS. السؤال الآن, what is KF and KFS? One of them is the normal fatigue stress concentration factor. The other one is the shear fatigue stress concentration factor. Now the question is, what is KF? Well, it turns out that there is a notch sensitivity. ببساطة يا شباب, يعني خلونا نكون واضحين, أنا ما أبغى أسألكم السؤال هذا, بس ممكن there is a possibility إن في واحد موجود في المجموعة, أنتوا عددكم الآن, إحنا عددنا هنا تقريبا 31 شخص, لو عطيناه فاكسين إبرة حتى حق كورونا يقوم يصيح. Maybe one of you is so scared from, you know, injections. So why? Sensitive, حساس الولد, وش نسوي فيه بعد? And there is a possibility إنه there are people who are sensitive to other things. You talk to them about money, they become sensitive. You talk to them about sport, oh, sport. واحد تقول له عن برشلونة ولا يكسر راسك. Sensitive. So it turns out that materials is not different than us. Materials can have sensitivity, and it is different. So there is a notch sensitivity factor, which is a Q. This Q is Kf minus 1 divided by Kt minus 1. Now look, and this is for normal. This one is for shear. What is this? This one is Q shear, which is Kfs minus 1. Same equation, but it is for shear, divided by Kts minus 1. Q turns out to be equals to 1 full sensitivity. يعني من تقول له شيء قام يصيح عليك ولا يعصب. Sensitive إلى أبعد الحدود. And there is 0. هذا واحد insensitive. تقول له قصة حزينة يقول لك يضحك. insensitive. It's the same story, which means that you can introduce a notch. Notch, يا شباب, is a mother word. It can mean crack, it can mean hole, it can, V notch, U notch. You bring two materials, you introduce to them exactly the same notch. One of them is sensitive, it fails so fast, and the other one is not. That's the meaning of the notch sensitivity. So if we multiply this by this and this by this, then what will happen? I will get Kf, which is equals to 1, multiply plus Q multiplied by Kt minus 1. لاحظوا, Kt is very simple, موجود في back of the book. It's exactly the same as the one you calculated from civil engineering. The only question is, what is the Q? What is the Q? That's the question. That's the new part. And then you will be able to calculate Kf. Now, Q, ya shabab, the notch sensitivity, for common alloys is listed here. Okay? So if you look at this curve, look at it carefully, ya shabab. This is the notch radius in millimeter. This is the notch radius in inches. Okay? What is the notch radius? إذا أنا جيت وقلت لك إنه في مادة في specimen في notch like this, هذا الراديوس حقه. If the notch has a hole, الراديوس حقه هو half of the diameter. If the notch has a groove like this, this is the notch radius. Do you understand? The depth, call it the depth. That's the radius of it. And if you know it, all what you need to do is to tell me, is this steel or aluminum? لو تلاحظون الالومنيوم ما عندنا الا لا خط واحد هذا اللي بالاخضر. بينما الستيل عندنا لا عدة خطوط. And if you look at them carefully, this one has an ultimate of 1400, بعدين هذا ultimate of 1000, ultimate of 700, ultimate of 400. فإذا أنا عندي مادة specimen في notch الراديوس حقه 1 والultimate strength is 400, which is 0.4 giga, the notch sensitivity is تقريبا Q equals to 0.62. هذه هي. That's a Q. خلصنا. طيب, what about shear? We said there is also Q shear. This is the Q shear. And this is the notch in millimeter. This is the notch in inches. طبعا الأسئلة اللي أنت ممكن تسألها تقول, what if I am beyond this curve? خلاص, if you are beyond this curve, use these values. What if you have 500? Okay, interpolate between 0.7 and 0.4. This is 500. So this is a Q. Find a way. There is, this is what is available and try to find a way using it. There is an equation which is called Neuber equation. Okay? Neuber equation says that Kf is equals to 1 plus Kt minus 1 divided by 1 plus square root of A over R. What is A and what is R? A is defined as the Neuber constant, and it is related to Q like this. Okay? And if you want to find what is A for axial unbending is like, this is the equation as a function of SUT, and for torsion, this is the function of SUT. However, these equations are only applied for SUT and KBSI. If you want to know the number exactly. Okay, يا أخوان. So this is it. One last thing before the time has finished. Cast iron يا شباب is notch sensitivity حقت الcast iron is very low, varying from 0 to 0.2. So in general, if you get a cast iron material, it is recommended that you use a Q as 0.2. You understand? So in the next class, inshallah, ya shabab, we will talk about fluctuating stresses, and what does that mean is when we introduce mean stress. So how do we deal with the mean stress? Because reality is not always sinusoidal and completely reversed. And that's it, يا شباب. Thank you so much. Yes, yeah, Majid.